Hello everyone, my name is Nashalian and my metric number is S22A0074. Today I'll be presenting my NLP project titled Malay-English Code Switch Sentiment Analyzer. This project focuses on sentiment analysis for mixed language text where Malay and English are used together in the same sentence, especially in social media and online reviews. Project background problem statement. In real-life communication, especially on platforms like Twitter, Shopee reviews, or WhatsApp chats, people often write messages using codes switching. For example, delivery lambat but quality okay. Mantap gila weh, I love this product. Service teruk, not recommended. The problem is that many sentiment analysis systems are trained on single language data, such as English only or Malay only. Because of that, these systems may not perform well when the input is mixed language. So my project aims to solve this by developing a sentiment analysis model that can understand and classify Malay-English mixed text correctly. Project objectives. The objectives of these projects are to develop an NLP-based sentiment classification model that can classify Malay-English code switch text into positive, neutral, and negative sentiment. To implement a complete NLP pipeline, which includes pre-processing, feature extraction, training, and evaluation. To evaluate the model performance using standard metrics such as accuracy, precision, recall, F1 square, and confusion metrics. To develop a simple web application where users can enter text and get sentiment prediction results. Data used. For this project, I used the MESOC sentiment dataset, which is suitable because it contains Malay-English code switched tweets. The data includes text tweet, tweet text, sentiment labels which are positive, neutral, negative. The dataset contains around 19,714 text examples and it is already labeled, which makes it easier to train a supervised learning model. System workflow or methodology. Now I will explain how the system works step by step. Step 1. Data loading. First, I loaded the dataset from CSV and extracted two main columns, the text column and the sentiment label column. Step 2. Text pre-processing. Next, I applied pre-processing to clean the text so that it becomes consistent and easier for the model to learn. The cleaning includes converting text to lowercase, removing URLs such as HTTP or www, removing special characters and symbols, removing digits, removing extra spaces, for example, raw text such as best gila lah, delivery lambat. Clean text, best gila lah, delivery lambat. This pre-processing is very important because social media text contains many noise elements. 3. Feature extraction using TF-IDF. After pre-processing, I used TF-IDF, which stands for Term Frequency Inverse Document Frequency. TF-IDF converts text into numerical values by giving height weight to important words that appear frequently in the sentence but are not too common across all the documents. So TF-IDF helps the model identify meaningful words such as lambat, teruk, not recommended for negative sentiment, mantap, best, good quality for positive sentiment. And step 4, model training using logistic regression. After feature extraction, I trained a supervised machine learning model using TF-IDF plus logistic regression. I split the data set into 80% training data and 20% testing data. The baseline model was trained first to get the initial performance. Baseline model results. For the baseline model, the performance results were accuracy 0.8734, weighted F1 square, score around 0.85. However, I observed one major problem. The model performed extremely well for the neutral class, but it performed purely for the negative class. For example, negative recall was only 0.14. This means the model detected only a small portion of actual negative sentences correctly. This happened because the dataset is imbalanced, where natural examples are much more compared to negative. Improvement or enhanced model. To solve the imbalance issue, I improved the model using class weighting. I retrained logistic regression using class weight equals to balanced. This technique gives more importance to minority classes such as negative, so the model is not biased toward predicting neutral all the time. Improved modeled results. After applying balanced class weight, the results improved significantly. Accuracy increased to 0.877, weighted F1 square improved to 0.88, macro F1 score improved to 0.75, and most importantly, negative recall improved from 0.14 to 0.68. This shows that the improved model is much better at detecting negative sentiment compared to the baseline model. So overall, the improved model is more reliable and balanced across all the sentiment classes. Application implementation. After training and evaluation, I implemented the project as a simple web application using Streamlit. The application follows the users to enter any Malay-English mixed sentence. Click the Predict Sentiment button, view the predicted label, positive, neutral, or negative. View the confidence score and probability distribution for each class. This makes the project interactive and suitable for real-time sentiment prediction. Application implementation. After training and evaluation, I implemented the project as a simple web application using Streamlit. The application follows the users to enter any Malay-English mixed sentence. Click the Predict Sentiment button, view the predicted label, positive, neutral, or negative. View the confidence score and probability distribution for each class. This makes the project interactive and suitable for real-time sentiment prediction. Application implementation. After training and evaluation, I implemented the project as a simple web application using Streamlit. The application follows the users to enter any Malay-English mixed sentence. Click the Predict Sentiment button, view the predicted label, positive, neutral, or negative. View the confidence score and probability distribution for each class. This makes the project interactive and suitable for real-time sentiment prediction.